No time to waste, so let's give a warm welcome to Juliano Costa, CNCF Ambassador, developer advocate from Datadog.
I just forgot to unmute myself. Hi, everyone. Thanks for joining. Cool. Well, I would like to start with a question for all of you. How many of you have, at any part of your application, I think it's a bit of overlap with what Dotan just said, but let's go. How many of you have, at any part of your data, a metadata or something in a log or in an attribute called user.id? Okay, I see a couple of hands, cool. What about user_ID? Okay, I see another couple of hands. Or user ID camel case. Okay, or even USR ID. Cool, so now I want to ask, how many of you have seen things that are exactly the same but named differently? Awesome, cool. So, welcome to, I think the clicker is not helping me much, but yeah, I'll try again. Welcome to the Smells Like Clean Telemetry. By the end of this talk, you will walk away with some best practices on span and traces management. I'll just do that. My name is Juliano Costa. I'm a developer advocate at Datadog, and here are my greatest hits. I'm a CNCF ambassador. I run a meetup in Linz, where I live in Austria. I'm an OpenTelemetry maintainer, and I also contributed to the OpenTelemetry certification. Cool. So to start things off, let's get a bit of context to everyone. So let's start with discussing what is a span, or actually, what is a log? So imagine you are seated at home listening to music. You have a piece of paper and you are taking notes of the songs that you are listening to. So at 106, you listen to Smells Like Teen Spirit. At 111, Come As You Are. And at 115, Something in the Way. I think you got the gist here, and most probably everyone knows what a log is. But we have a content, a message, what you have done, and the time. In IT, we have basically the same. We have the message that our services are producing, which service is producing that, the timestamp, and the level of the status of this log message. And cool, but Juliano, isn't this talk about spans? Yes. So what is a span? And to answer that, let's go back to the piece of paper. And here we have 3 log entries. And they are great to tell what happened and when it happened, but we don't know what happened before and what happened after. We don't know if they are related to each other or if they are related with each other. So let's expand a little bit this log entry into what we call a trace. So a trace is composed by spans. Each span is an activity that happened within that transaction, that trace. So let's think about the trace as a container, and then everything that happened within a transaction, it's its own span. And the size of the size of the bar shows how long that activity took to execute. So we have the play song, which is longer, actually the whole duration of the activity, and then buffer audio, stream audio, and update stats in a play song scenario. Cool, let's take a look at a closer look into what a span has, the metadata that it has. It has a couple of things that we are already expecting, such as the span name, start time, and end time, so we can actually calculate the duration of it. But it also has a couple of extra stuff, such as the context. The context is pretty important for a span, because whenever the span starts, it creates a span ID to identify itself. Perfect. This is pretty basic, but if it is the first span in a transaction, so if there is no incoming context arriving to this span, what the span does is that it also creates a trace ID to identify the transaction. So we have a trace ID and a span ID now as part of the context. Cool. So now let's say that the play song calls buffer audio, but in this call, it actually passes the context. So play song is calling buffer audio, and I'm passing the trace ID and span ID as part of the request header. And when buffer audio span is starting, it already has a context. So I know that I have a trace ID, and I know that there is another span that is calling me. So what actually buffer audio does, is that it sets a parent ID with the span ID that is calling. The trace ID, it doesn't create a new one, it simply uses the incoming one, and it creates a new span ID to identify the buffer audio. So this is how the tools, the observability tools, can correlate and have a hierarchy of the whole transaction, who calls who, and how you navigate that transaction. Great. It's awesome to have all that information, but imagine you are on call and you got a call, an incident with a specific user having an issue. How do you find that user in all the transactions that you have? You have hundreds of thousands of active users. You would need to navigate a bunch of stuff. But spans also have attributes. So I can use attributes here, for instance, to tell the song name. So I'm saying, hey, this play song span is related to It Smells Like Teen Spirit. So I know that this song is related to this span. Great. And we can take advantage of that and add extra attributes that will help us as developers or as on-call folks to troubleshoot that further later if we need. So we can add user ID, we can add subscription type, or any other business metadata that you would need to whenever thinking about your future self, whenever answering the incident. And most observability vendors will allow you to query on that. So this is great. But make sure you are taking advantage of the attributes and not making a mess on your span. So here's the first tip. And, oh, where is it? Here it is. Let's keep one. Yeah. Here's a real example where the user added the whole JSON response body as metadata. The user didn't map key to value. It just got the whole JSON as plain text and added to as a metadata on part of the span. This data is not queryable. This data is not useful. This is just increasing the size of your span and also the size of your trace, and it's not helping you. So make sure that if you need all the information from JSON, make sure you map the keys to the values. So then this is actually queryable. Great. So cool. Now that we have set the stage, I want to start the talking about logs versus spans. And let me just call out here that it's not about one versus the other, but actually when to use one and when to use the other. So logs are great for audit and compliance. So let's say that user Eddie Vedder tried to access Nirvana unreleased songs and got access denied. You can get this log entry, store for 10, 20 years in a cheap storage and forget about it and just get if you need. But how many of you have logs like this? So you have a function. Whenever you start a function, you have a log saying, hey, this function is starting. And right before returning or ending the function, you have another log saying, hey, I'm ending this transaction. How many of you? Does anyone have seen things like that? Okay. for the ones that were brave enough to say. I'm sorry to tell, but this is not a log. You are literally tracking the duration of the transaction. This is a span. And in Python, for instance, we could replace the log entries with the @tracer decorator. And whenever this transaction is called, it starts a trace. Right before ending, it ends the trace. So I just need to pass the span name and the kind. And you would have a span there. Cool. So let's talk about how spans are actually created. For that, we need to instrument our application. And there are 3 different ways of instrumenting your application. One is the auto-instrumentation. You have an agent, a file, or a script that you will call. And as the name says, it will automatically instrument your application. So I have an example here in Java. Step 1, I download the OpenTelemetry Java agent. Step 2, I pass this Java agent as a JVM argument to my JVM. And step 3, I start my application. So you see on the step 3 here, I'm not saying anything I'm starting as I would start my Java application. But the JVM understands that now I have this dash Java agent that it needs to start the Java agent together with the application. And when that happens, what we get? So we get Tomcat data, we get Spring data, we get Hibernate data, and we get JDBC data. So I didn't change anything on my code. The Java agent went there, found all those libraries, and instrumented. So whenever something was happening, some interaction in Spring with those libraries was happening, the agent simply instrumented for me. And talking about libraries, that's the second way of instrumenting your application. So library creators or the community have released a couple of instrumentations for specific packages or libraries. And you as application owner, you can simply import those instrumentations, add to your code, do some minimal changes on your code, and then you get this package instrumented. I have an example here in Rust, where I'm using a framework called ActixWeb, and there is an OpenTelemetry instrumentation ActixWeb package. So this is maintained by the OpenTelemetry community. I just went to the docs. Okay, I need to add this to my cargo file. I need to add this dependency and this import. And then whenever my server is about to start, I wrap my handler in this request tracing that is coming from this package. So whenever a user calls my handler, I get a span. So this REST application is exactly the same as the Java application, but in this case, I just instrumented the web server, so I'm just getting one span. Cool, and the last one is the hardest one, or let's put it that way, the one that requires most effort from the developer, which is the manual instrumentation. So for this one, why is hardest? Because to start a span or to create a span, you as application owner, as developer, you need to go and say, hey, I'm starting a span. The span will be called that. Here are the attributes that I want. You also need to take care of propagating the context. So we have an example here in JavaScript. We can see that it's way more verbose. So the first thing that I do is getting the incoming context. Then I create my span, giving a name, kind, and then I have a set of attributes. All those attributes I'm using semantic conventions. More on that later, but Totten already briefly mentioned in his keynote. And then I do whatever I need to do in my method, and I need to make sure I end the span. So we can see that it's way more verbose, but the thing here is that if I don't need one of those attributes, I can simply remove the line. If I need to add something more business context to that span, I can go and add it. So it's more verbose, but the telemetry that you get out of your code is more meaningful to you, and you can fine-tune that. Cool. So, and whenever this is called, again, we get a span. So it's way more verbose than the Rust example, and we cannot not even compare with the Java example because there was no code change in Java, but we get a span. Cool. And before we go deeper on the span itself, one thing that I want to call out is that we have the auto-instrumentation and instrumentation libraries. They are great to bootstrap observability. So if you do not have any visibility into your application and you want to see what you get out of it, auto-instrumentation and instrumentation libraries are great because the effort to instrument is pretty low, but don't let things come as they are. And I'll show you why. I have another example here, same application, but now I'm using a Express framework. And the Express framework, let's put that way, the Express instrumentation on OpenTelemetry is known to be noisy. So I got here 17 spans, and out of those 17, 7 are TCP, TLS connect, and DNS lookup. I think if you are an Express framework developer, this information may be useful for you. But if you are an application owner for the songs application that is querying the songs and stuff, maybe this data is not actually helping you. So check with your peers, check with your team. And if this information is not useful and it's not helping you, disable them. So here I have an example again in JavaScript to disable this instrumentation, but each language has its own way of disabling this, so just check the docs and use it. You, your bill, and your teammates will thank you later because the trace will be more concise and like more meaningful. The data that you get is more useful for you. If for some reason you do not have access to the code or you do not want to change the code, you can use another part of the OpenTelemetry project, the OpenTelemetry Collector, and put something in the way. So I have here a filter processor where I'm filtering out everything that is coming from the instrumentation-net or instrumentation-DNS. And with that, I get a smaller span. So like more meaningful, just focus on the things that I can act. Be careful with this approach though, because as I said, there is a relationship between parent and child spans, and this relationship creates the hierarchy of the trace. So just for the demoing, I removed the request handler instrumentation, so the Express instrumentation here, and what happened was that the hierarchy of the trace is broken. So I still get all the data, but the navigation is not the same. So then make sure you validate what you're getting out of it to not mess up your experience in the end. Great. Now coming back to the spans, something that we didn't have visibility, now we can milk it. And just a call out here, Milk It is from a different album from Nirvana called In Utero, but never mind. Cool. So we have here what I recommend is take advantage of the auto-instrumentation and instrumentation libraries, and using it together with manual instrumentation. So instead of creating the span, managing context propagation, ending the span, adding all the attributes that you want to it, and all the verbosity that we saw on the manual spans, we can simply let the instrumentation libraries and the auto-instrumentation instrument our application, and then we can simply get the active span and add business attributes to it. So here I'm adding the media song, the artist name, and also the user ID. So now this is part of the span that I'm getting. So all the performance that I was getting already from my application, now I'm also getting business insights together in my observability platform or in your backend. And of course, you can also extend the instrumentation and still use the manual instrumentation to add visibility into the things that you didn't have. So in Rust, we didn't have the database call instrumentation. So I went there and created a span whenever my database is called, give the name, everything, do whatever I need to do, make sure I end the span, done. So something that we didn't have visibility, now we have. So now I can see that from 11.42 milliseconds that my request took, 11.19 was spent on the database call. So yeah, this is where you can kind of see where the time is being spent. But there are a couple of things to stay away from, that you should stay away from. Whenever you start doing this process of instrumenting your application, it's very tempting to want to know everything that is happening on every single function that you have on your code. And this is called over-instrumenting. So you can see here I have a couple of microsecond spans and things that are not like actually useful and meaningful for me and my team. So make sure you're not recreating the noisy express instrumentation on your own. Focus on the things that are important to you. So I have here another, well, the same example. So I have the incoming request, I have the database call, I have an outgoing request, and another database call. So those are the things that my team is implementing, and my team can act and improve and troubleshoot. Cool. Another thing to stay away from that will drain you, and that's something that Dotten mentioned on his talk, is not following semantic conventions. So semantic conventions give us a common name for different kinds of operations. OpenTelemetry has OpenTelemetry semantic conventions to follow. And so let's say that we want to record as part of our trace, as part of our span, the request method. Should we use hp.request_ method? Should we use hp.method or hp.request? So one, who thinks is one? Second? Okay, the third? Okay. Well, I'm sorry, but you shouldn't use any of those. Yeah, that was a tricky one. Yeah, I know. But OpenTelemetry has a stable semantic convention for HTTP spans, and we should stick to HTTP request method. And this is pretty simple to solve and align, because if you are using OpenTelemetry to instrument your application, the telemetry that your application will produce already follows the semantic conventions. This is great. If you are using a framework that doesn't have a support on OTel, you can go to the OpenTelemetry docs and check what is the semantic convention for that, and then use it. This is pretty simple. But one thing that we do not discuss much, and we should, is about not having company-wide semantic conventions. So within your peers, within your company, should you call it your environment name production, prod, PRD? I don't know. This is not on me. This is on you and your team to sit and discuss, align, agree on a value, and then once you agree, make sure everyone is using the agreed value. Because imagine you are trying to create a red matrix dashboard, a simple one, request, errors, and duration, or latency here, and you want all your production services metrics in here. If you have agreed on a value, you would simply get those three metrics with tag production, or prod, or PRD. And then here you see already, it's like something that should be simple starts to add up, and you have like to pipe a bunch of different values. Here is just, we have just 3 different values, but let's say that your team is, for some reason, adding the team name in front of the value. So that just adds up. If you have 10 different teams in a company, that would be a mess. And within the team, if they don't use the same attribute, then that would be like even messier. So stick to a value that will make your life easier, and I'm sure it will even save you some money later. But it's always good to have this endless task of instrument, validate, prune, and add. So your application changes, OTel gets new features, the ecosystem evolves. So make sure you add a task every quarter or something like that to revisit the spans, but also the telemetry in general that you are producing. If you are using it, if that's useful. If it's not, just drop it. You are missing something, add it. And then have this instrument, validate, prune, and add forever. And to help with that, I have two heart-shaped projects that I want to share. One is the instrumentation score. This is a project that introduces a calculation formula to your telemetry. It is still a new project. Let's see how that evolves. Hopefully one day it merges into the OpenTelemetry spec itself. And another one that I want to actually spend more time is OpenTelemetry Weaver. It's also another tool that the OpenTelemetry project provides. With Weaver, we can validate, define, and evolve the telemetry that we produce. So with Weaver, we can, for instance, create docs for our own telemetry. So we can see here that all the media dot whatever, those are metrics that are for my application. And we can have this in a wiki, in somewhere that is accessible for the whole team, and everyone checks that and align on that. You can also use Weaver to create the classes or the constants that you have defined for your telemetry, so for your attributes. So you need to play a little bit with Jinja templates, but it's doable. So here I have a Java class that it creates the constant that I need, the Java doc. So if I can share this class with all the Java developers and say, hey, whenever you need to use, create a span, stick to the semantics that we have on this class. And we can also use Weaver. I think this is the most valuable thing out of it, to validate the telemetry that your service is producing. So you can add Weaver to your CI/CD pipeline. So in a GitHub action. So whenever a user is sending a PR, you configure in a way that your pipeline sends a request to this new feature, new service, and this service points the telemetry to Weaver, and then Weaver will print out like, hey, media song is a deprecated value and should be replaced by media song name, and media artist doesn't exist in the registry. So then as it fails, it blocks the PR from getting merged, and you avoid having non-compliant attributes on production. And with that, the user that is sending the PR can either check the docs that was already generated by Weaver to see, okay, so media artist doesn't exist, which one should I use? And if he doesn't find, also tell like a process or explain a process to request a new attribute to be added to the registry. And to wrap things up with no apologies, I have 4 takeaways that I want you to walk home with. 1, use logs only where you have to. Spans will give you way more context. Enrich existing spans and add spans where you don't have visibility. But hooking on that, do not over-instrument. And last, revisit, validate, and evolve as you go. So for the ones that like to take pictures of slides, I have all of them together. But I also have all these slides already shared on my personal blog, jcosta.dev. And I have stickers from the character that I drew. So feel free to come and grab some. Thank you.
Thank you, Juliano. Thanks for reminding me all the cool songs of Nirvana. I need to listen that again. And are there any questions to Juliano? I'll give you a mic.
Thanks for a great talk, and thanks for
you.
the mention of the keynote. Actually, more than a question, it's a comment. You had a great example about the environment, prod, production, PRD. So I'm happy to share with everyone that's actually a new semantic conventions special interest group that we're starting in OpenTelemetry specifically for service and deployment. We even had the first call yet, but that's supposed to be giving, as part of OpenTelemetry, standardization on how you call your environment resources. So hopefully to have this at least as part of OpenTelemetry semantic conventions, but of course lots of others that you may want to suggest for this SemConv SIG, and also we'll always have something for your own organization that you'll need to map out. So just want to comment on this one because it's a new
Awesome.
development in OpenTelemetry. Thank you.
Thank you.
Thank you, Dotan, for comment. Any questions?
Wonder?
Thank you. Great talk. I've got one question because you show us the span from tracing, and at the beginning we start with logs. And yeah, that's true. We sometimes have this beginning ending the logs part. And I'm just wondering, maybe it's not a good idea, but is there any solution to automate that kind of context in the logs that you can define that, okay, this is the same, let's say, content of the logs? Is there anything, or you need to set up by your own?
Yeah, I think you need to set up by your own, unfortunately. But I know some companies that have created their own backend to kind of get those logs and transform into spans, which is kind of a overhead. Like they're just creating like all these screens are from open source project. All these screenshots are from an open source project called Jaeger. And Jaeger is for visualizing spans. And basically companies that have those type of logs to track the transaction duration, they build their own thing to do that. I don't think it's a good idea. It's way simpler to replace it. And of course you cannot like shut off and turn on a new thing. It's a gradual process of migration.
Okay, thank you.
Thank you.
Any other questions? Then again, thank you, Juliano.
Thanks again.
And now coffee break, and we will be back here at 10:55.